Hey folks, so today we're going to talk about calculators and what you need from your calculator, how you're going to use your calculator, and some really important concept called significant digits. Now, before I get too far into this idea of calculators, if you don't have a calculator, it's time. You're in college. Go get a calculator. Yeah, some students like, oh, I can just do it on my phone or I can use the computer calculator or whatever. The thing is that that can increase the amount of time it takes to do your homework by it can double it almost. Your mental health is worth the $15 that it's going to take for you to go out and just buy a calculator from that. You don't need one of those fancy schmancy graphing calculators. I used a calculator just like this all the way through my doctorate. You can too. Key things that you need to have are the scientific notation button. Now, on this calculator, it's right here. It's an EE. On some of your calculators, it'll be printed kind of in blue right up here, which would mean you have to do second function and hit the button to get to it. Sometimes it's down here at the bottom from that. So you need to find it. So pause the video, pull out your calculator, and find that right now before you go any further. Now, the thing about the EE button is this is your times 10 to the button. We're going to talk about scientific notation. Hopefully, you run into this in high school. But the example that I gave before during the orientation was if you have 5,000, you can write that as 5 times 10 to the third. We'll talk about how that works. But you would put that in as 5 EE3, done. Never, ever, ever do 5 times 10 raised to the third. That will work as long as you're multiplying. It will not work the first time you divide. And unfortunately, you don't need to divide until later on in the semester. And so you'll be sitting there happily going along the way you've been doing it, and you'll be getting it right. And then suddenly it won't work. And that's really frustrating. So it's better to go ahead, get yourself a real calculator, and make it work. So one of the other things that we're going to talk about is significant digits. So, if a lot of times your calculator will give you something like, 5.2458793 or whatever, you do not need all of those digits. Those last digits are literally random numbers. They mean nothing. And so when you're putting those digits down, technically you're wrong because you're making a claim that you can't support. You didn't measure it that precisely. And so we're going to talk about the difference between precision and accuracy. You need to be accurate, but then you've got a limit to the amount of precision that you can do. And in a lot of cases, that's going to be 3 significant digits of precision. So, if it's 5.2458542, 3 significant digits would just be 5.25, done from that. So you don't need to write down all these numbers in the calculator. You don't even need to save them because you're wasting your time with that. We want to give you the tools that you need to get through this a lot more quickly. All right, let's look at it in detail. Let's get started. We're going to be, as I said, we're going to be talking about calculators. So make sure you've got your class notes out. This is going to be tool 3. Looks like this. Remember that your class notes are always front and back of one page. So that's the back side. And then this is what your practice sheet looks like. This is what you'll be doing for homework. Pause the video till you've got that out, then let's move on from there. Ready? Okay. So let me ask you, how comfortable are you with math? Does the thought of you doing math make you see this? I can help you with that. So, if the thought of doing math makes you curl into a fetal ball and kind of rock back and forth, come see me. Give me 15 minutes in live help, and I can show you all of the math that you're going to need for the entire semester, and you will be fine. We will get you through this. It'll be okay. But it is a science class, and all science is about math. When it comes down to it, you're like, oh my God, I hate the math. Most of the times, I find my students actually love the math. It's getting to the math that they have the problem with. Once you've got the math, the formula, and you put it in your calculator, most of you do just fine with that. It's figuring out which formula and what these different numbers that go into the formula mean. That's where the problem is, and that's the science, not the math. So science is a way of describing the world. So here's a description about the world, and it's one that we're actually going to use in the class. So as the temperature of an object goes up, the wavelength of light it emits gets smaller. And so we'll talk more about wavelengths and all this other sort of thing. But basically, just the short answer is light is these wiggles that's moving through space-time. A long wavelength looks like this. A short wavelength looks like this. So what this observation is that the temperature of an object, as it gets warmer, then the wavelength of the light emits gets smaller. So here's how we might write that down. So this is the first of an example of relationships. We're going to talk about between directly proportional and inversely proportional. Directly proportional means as one goes up, the other goes up, or as one goes down, the other goes down. Inversely proportional means as one goes up, the other goes down, or as one goes down, the other goes up. So they move opposite. So this one is inversely proportional because as the temperature goes up, the wavelength is going to go down. Let's see how that works. So if you think about it, let's see where my pen is here. Here we go. So if you think about it, if I have 1/4, all right, if I make this bottom number get bigger, what happens to the overall value of the fraction? Well, 1/8 is smaller than 1/4, which any kid who's ever tried to share a candy bar can tell you, right? So as this bottom number goes up, the whole fraction goes down. So that's what inversely proportional means. So as the temperature goes up, the wavelength, it's up here, is going to go down. All right. So this formula, this equation, does nothing more than encapsulate what all these words say. And so the reason that we write it in this form is because scientists are lazy. Do you really want to write down all of this, or would you rather put it in this short form right here? And so this particular number right here, this is called a constant. And this is just shows how much of the relationship. This is allows you to actually get details because sometimes we need the details. So if I know specifically what my temperature is, I can do 2897768.5. I can divide that by the temperature and that gives me the wavelength. What we're going to do in class a lot of times is the opposite. I'm going to actually solve this equation for temperature. And then once I measure the wavelength, I can figure out the temperature of the object, but we'll get there. Sometimes we're even lazier than that. Wavelength has, look at that, that's got 9 letters. Temperature has a whole bunch of letters. That is way more letters than I want to write. So we use a symbol because we're too lazy to write out the whole word. And so T here, we're saying means temperature. Will it always mean temperature? No. Sometimes it might mean time. Sometimes it might mean tempo. It could mean anything. You get to decide. Since you're the scientist, you would write this out and then you would say T equals temperature, just so that everybody knows. This little symbol here, this is actually a Greek lowercase letter lambda. And most of my students end up just calling it chicken foot. I don't care what you call it. It doesn't matter. You can call it smiley face or chicken foot or whatever. The thing I want is whenever you see this symbol, I want your brain to say wavelength because that's what that is. That's the wavelength. So you see that you can start getting formulas that look kind of all alien and esoteric and smart and all that other sort of stuff, but really it's just because we're lazy. So if I give you the temperature, you do 2897768.5 divided by the temperature, and that gives you the wavelength. Okay. So we talked about how if you've got your calculator, it's going to give you a whole bunch of numbers. So the thing is that you don't need all of those numbers. So we need to talk about the concept of significant digits. Significant digits is about precision. So look at the example here. Let's suppose you've got $113 in your bank account. If somebody says, "Hey, Ben, how much money do you have?" If you say you've got about $100, are you lying? Think about it. Are you lying? No, right? I mean, you do have about $100. You're being accurate, but you're not being precise, which is fine. There's no reason for you to be precise with your buddy when they're just asking how much money that you have. So this has one significant digit of precision. The more significant digits you have, the more precise you're being about that number. So you can see that this is one significant digit. 100 is one significant digit of precision. I've got one non-zero number. These non-zero numbers are not significant. They're just there for accuracy. Because if I got rid of these, let's say your bank said, okay, well, I'm just not going to give you these 2 zeros here. And so you've got $1 there. Are you happy? Probably not, right? So those zeros are just placeholders. They're there for accuracy. Because if you don't have those zeros, then the number is not accurate. One, if you somebody says how much money do you have, and you say I've only got $1, you're lying. You're not being accurate. So, but we're not necessarily being as precise as we could be if we only have one significant digit. So we can do a little bit better than that. So let's suppose that you say, somebody says, how much money do you have? And you say, I've got about $110. You're still being accurate, aren't you? And some people say, oh, well, I'm being more accurate. You're actually not. Accuracy is you are accurate or you are not, period. When we're talking about precision, we're talking about how more detailed you've got, how precise you are. So $110 is still accurate, but it's a little bit more precise than saying you've got $100. So you've got two significant digits of precision. More significant digits of precision means that you are being more precise. So you see that it's two because I have two non-zero numbers here. All right. So talking about then the accuracy, suppose you've got $113 and you say, I've got about $1. This is what we were talking about before. But so it's not accurate, right? But here's the thing that confuses a lot of people. It is just as precise as saying you have 100. Think about that. That might blow your mind a little bit. So if you have one significant digit, this has one non-zero number. So you're being precise. Now, if you said I had $1.0, now you're being even more precise, but you're still wrong. You're still not being accurate. Do you see the difference there? This is the part that gives people willies sometimes. So if this shakes you up, just think about it. Precision is not accuracy. Precision is not whether you're right or wrong. It's how carefully you're measuring it. And you may say, well, if I'm measuring it carefully, aren't I always going to be right? No. What if your equipment is wrong? And that's what's happening a lot of the times when we're talking about significant digits. We're measuring to the limit of my equipment. So if I've got a ruler, and I'm trying to measure something that is 5 miles away, 5 miles across, and I'm just flipping that ruler over and over and over, there's going to be some small precision errors in that. And you say, oh, well, okay, so it's human error. Well, not necessarily. Maybe I have a piece of equipment that takes a picture, once a second. And something happens though in between those 2 second flashes. Well, the camera can't do anything about that, right? That's just the limit of what it's got. That's the limit of its precision. Most of the equipment that we use here in astronomy has 3 significant digits of precision. So for that reason, I always want you to report your answers to 3 significant digits. Okay. So here, this is a case where let's suppose you have 113.10, so $113.10. So if you have this much, then and you said that you had 113.1, well, that's just 4 significant digits. Do you see why? Pause the video and think about it. So I've got 4 significant digits with that. If I say that I have 113.10, now I've got 5 significant digits. And you say, wait a minute, Kilo, you just told me that only the non-zero numbers were significant. True. But think about this. If I got rid of that 0 right there, would the number change? Is 113.1 the same as 113.10? Sure. So that 0 is not there for accuracy. It's accurate whether it's there or not, right? So the only reason to put it there is to say, hey, dummy, I measured this more precisely. It's not 113.11, it's 113.10, by God. And so that is a significant digit because it's there for precision, not accuracy. So the simple test to decide if something is there for accuracy or precision, so if it's there for precision, it's significant, then just cover up that number. If the number changes, then if it's not accurate, then it's just there for accuracy. So let's look at this case. If I have 100, if I cover up those 2 zeros, the number is different, isn't it? Do you see that? And so therefore, those zeros right there are just placeholders. Okay. Now, this same idea applies to numbers that are less than 1. So if I have the number 0.0134, we want to know how many significant digits. Well, let's use our little test. We know you're probably going to say there's either 3 or 4. That's the most common answers that we get from this. So if you cover up that 0 right there, is 0.134 the same as 0.0134? Let's say this is your blood alcohol content. There's a big difference, right, between 0.01 and 0.1. One of these you're legal, the other you're dead. So that 0 is not there for precision. It's just there for accuracy. because the number is not correct unless I put it there. So therefore that one's not significant, and so I have 3 significant digits. Okay. All right. So now take a look at your class notes. There's a table there. I want you to pause the video and I want you to give your best guess to how many significant digits each one of these values are. So your table looks like this. I want you to tell me for each one of these values how many significant digits they are. Pause the video, work it out, and then come back. Did you pause the video? Make sure that you pause the video. Okay, I'm going to trust that you've actually got that. So let's look at each one of these. So for 132, this one's pretty straightforward. How many significant digits do you think? Yeah, so there's 3 significant digits here, right? 1, 2, 3. There's not any zeros. All the non-zero digits are significant. There's 3 significant digits. We're good. This one's a little harder. So 5.40. You probably either said there are 2 or 3 significant digits. So let's use our test. If I cover up this 0, does the number change? No, 5.4 is still the same thing as 5.40. So this number is not there for accuracy, so it must be there for precision. If it's there for precision, then it is significant. So this is 5.40, so this would be 3 significant digits. Let's go ahead and fill in our table here. 5, 10. So 3 significant digits here and 3 significant digits here. Now, let's look at this one right here. Now, this one's a little bit harder. You probably again would say there's either 2 or 3 significant digits, right? So there are 2 non-zero numbers, and you're saying, well, but if I cover up that 0, then the number changes. So here's the last rule that I'm going to give you. Interior zeros are always significant. You don't have to think about it. And if you think about why, so this one is an interior 0, so it's significant. And the reason it's significant is because this one is significant. So I'm saying I measured it all the way out to the 1,000th place. Well, if I measured it out to the 1,000th place, then the 100th place is also being measured precisely as well. So it's just a coincidence that it's a 0. That could be, 1.111 or something like that. But because I'm measuring this one so precisely, that means I'm measuring these precisely too. So if that's confusing, just remember the rule. If I have interior zeros, they're always significant. If you got questions about that, come and see me, because that one usually confuses a lot of people with that. All right, looking at the number 10, how many significant digits do you think? So in this case, there's actually just 1, right? There's 1 significant digit. So the reason for that is if I cover up the 0, I get a different number. And if that gives me a different number, well, then that means that it's only there for accuracy, so it's not significant. 5.4 then, this one's also pretty straightforward. There's only 2 non-zero numbers, so that one is going to be 2. This one is like the example that we gave in the few slides back. That 0 is just there to keep it accurate. Because think about it, if it's your blood alcohol content, there's a big difference between 0.011 and 0.11. Because 0.11, you're dead. So this is only there for accuracy. It is not there for precision, so it is not significant. And so there are 2 significant digits in that one as well. So how'd you do? Sometimes this takes some getting used to. There's actually an easier way. Some people say, you probably heard in high school when you talk about scientific notation, it's like, oh, it's how we talk about really big numbers and really small numbers, and that's why scientists use them. Well, no. Scientists use them because we are lazy. Because in proper scientific notation, every digit is significant. You don't have to think about any rules or anything like that. If you want 3 significant digits, you write down 3 numbers, by God. If you want 5 significant digits, you write down 5 numbers. You never have to worry about it. And so in this class, Smart Sparrow in particular is going to expect you to put in your answers to 3 significant digits. So if you always use scientific notation, you never even have to think about it. And that is why we use scientific notation, because we are lazy. So let's review scientific notation and how it works here. So this is our 113 number. Proper scientific notation has one digit in front of the decimal and all the rest of them are after. So if I want 3 significant digits here, then I'm going to write down 3 numbers. That happens to be how many I have here. I would write down 1.13. But then I need to tell you how many places to move the decimal. So to get the decimal back to where it needs to be, I move it 2 places. So I write this as times 10 to the second. So 2 places, we'll put it where it needs to be. So that's 1.13 times 10 to the second. Just remember on your calculator, that times 10 to the is your EE button. So you would put this in as 1.13, let's clear this up, 1.13 EE, which is times 10 to the 2. And that's it. You don't have to hit equals. You don't have to do anything. Now, take a look at my screen here. Do you see how the O2 is kind of up in the corner up there? Some of your calculators will do that. That means times 10 to the second. So if you've only put down 1.13, you're wrong. There's a big difference between 1.13 and 113, which is what 1.13 times 10 to the second means. So on some calculators, it'll say 1.13 E2. That's fine too. It means the same thing. That E means times 10 to the. In Smart Sparrow, when you're putting in a number in your labs and in your assessments, you need to use the E. So you would type this in as 1.13 E2. So 1.13 E2. It actually doesn't matter if it's a capital or a lowercase e. You cannot put it in Smart Sparrow as times 10 raised to the second. That's not okay. It will reject that because you need to be using your scientific notation button. So 1.13 times 10 to the second is 1.13 E2. Got it? Okay. Now, if the number is less than 1, then I'm going to have a negative exponent here. All that means is the number is less than 1, move the decimal to the other direction. So again, I would start off with my decimal right here. I moved it 2 places to the left. So that's times 10 to the minus 2. And you would put this in on your calculator in the same way. It would be 1.13, and then you hit EE. Now on mine, I need to hit the plus minus button here. Don't hit the subtract button. Hit the plus minus button, and then it would be -2. So on my calculator, it looks like this. On your calculator, it might be 1.13 E minus 2. If you've got one of those awful X10X buttons, it might be writing out the X10X, but you remember you cannot put it in Smart Sparrow that way. That's why I don't recommend that you actually use those. And if I were going to put this in Smart Sparrow, I would write this as 1.13 E minus 2, just like that. All right, again, if you have any questions about that, make sure that you come see me. We'll get you going not too long. So with scientific notation, then, if you want to show fewer significant digits, you just show fewer numbers. So this is 2 significant digits. It's 113. So I wrote down 1.1 times 10 to the second. This is still, if I were to work this out, 1.1 times 10 to the second, then I would move this 2 places. 1, 2. And you see how that's 110, which was the example that we gave before as having 2 significant digits. Same thing with the 0.0134. I only need the first 2 digits, and so it's 1.3 e to the minus 2. Now, a quick note, if you are dropping digits, if this is 5 or higher, round up to the next one. So if this had been 115, I would write this as 1.2. That probably makes sense to you. If it's 5 or higher, just round up. So suppose your calculator shows this. Remember that you don't need to show all those significant digits. So if we want 3 significant digits, we're only going to keep these first 3, but I need to decide if I need to round this up or not. So I look at this 4th digit. Is it 5 or higher? Yeah, it's 5 or higher. So I'm going to round this up to 66.5. Do you see that these two are basically the same number? They're both accurate. But if you wrote this number out, you would be claiming that you measured this to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 significant digits. All right, if you measured a number to 12 significant digits, then you have such super secret top level spy equipment that you must work for the NSA, in which case, don't tell me I don't want to know. there is no way that you measured it that precisely. In most cases, all you really know is that it's 66.5, and that's it. Okay, so we talked about this with your scientific notation button. You'll never enter this in as 1.1 times 10 raised to the 2. Never, ever. Don't do that. You just put in 1.1, hit that EE, it might be EXP on your calculator, and then 2. You don't hit equals after it. Just treat it as a number, just like that. All right, so in summary then, we use equations whenever we need the details, but a lot of times in this class, you're going to be able to answer it just by knowing which one increases, which one decreases, and are they directly or inversely proportional. We're going to use that a lot because that's the science, and that's what I care about. However, sometimes you do need the details. And so when you need to do the details, then we're actually going to do the math using the equations. You have an equation sheet in your resources page, so you might want to go ahead and download that so that you can see the equations that we're going to be using. Significant digits, remember placeholder zeros are not significant, whereas interior zeros are always significant. And then we talked about scientific notation, how really honestly, I would just use scientific notation all the time, and then you just don't even have to worry about significant digits. I will warn you that if you don't put your answer to 3 significant digits, there is a chance that Smart Sparrow will tell you that it's wrong. Sometimes it will look at your number, you'll type in this big long number, when you move into the next field, it will convert it to 3 significant digits, or if you put in scientific notation, it'll convert it to standard notation for you, saying, hey, is this what you meant? If it looks good, great. If it doesn't, you did something wrong. Figure out what's going on with how you put in your number. So it's just trying to do you a favor and give you a little extra check on that. But it won't always do that, so you can't always count on that. All right, so that's it for this one. Go ahead and download your calculator's practice worksheet if you haven't already. Once you've filled it out, scan it or take a picture of it and submit it. And just as a reminder, it's going to be graded for accuracy as always. Okay, guys, that's it for this one. And it's real important that you get a good grasp of what's going on with your calculator and how to use it. I also suggest that you look at Excel or Google Sheets. You've got access to both, just kind of whatever you're comfortable with from that. Google has it, and Excel have their own specific ways of entering things in, but it's basically like what you're going to see with the calculator. So, for example, if you want to put in 5 times 10 to the third, you'll put in 5e3, just like we've learned. So the way Smart Sparrow wants it and the way Excel wants it are identical. And setting up your equations in an Excel spreadsheet can be really useful because it really just makes this class a lot easier. So it's optional, completely up to you. But if you want to learn how to do that, pop by Live Help, give me 15 minutes and I can show you how to do it and you'll be good to go from there. All right, we'll see you next time.